First, a few words about myself. My name is Pär Åberg, and I have been working in the data industry for almost 20 years. 18 years as a system integrator, building the data center with all the physical infrastructure. And now since almost 1 year and a half at Swegon as business development manager. Well, we used to say that the data center is the fastest growing industry in the world. I think you maybe can find out why, because we are using so much IT today. 20 years ago, when I approached the industry, I was using my phone to make phone calls, actually. I was not streaming videos. I did not use my phone to identify myself when I was going to pay my bills. I did not upload photos of my social activities. But today I am. I'm using Spotify, I'm using Facebook, I'm using Twitter, I use YouTube to show to customers new videos, new techniques and new trends. And I'm very, I need to have IT almost everywhere I go. I need to have it with me. And it's going to be continued. If I said that I was only using my phone for phone calls 20 years ago, let's see in 20 years what we will use IT for. It will grow, that's for sure. And it's going to grow very fast and furious. The only constant I have been noticing the past 20 years is that it's changed a lot, and it changed very fast. So what was the truth 20 years ago when we said we should have 20 degrees in the server room, all over the room, is not the truth anymore. We're talking about keep the cold where it should be and the hot where it should be. And we also want it to go very, very fast because we want no latency. It shouldn't take too long to use your phone to pay your bill or check your emails. And because of that, it's quite dangerous, I would say, because when you use a new app in your mobile phone and it says, okay, we have an update today, can you please confirm or agree on the new updates? And the question is yes or no, and you press one directly, yes directly, because you don't need to wait. You have no time to read those 3-4 pages or maybe 20 pages or maybe 400 pages. But what you don't realize, perhaps, is that your photos is given to someone else. They own your photos from that time you upload them. And they are actually have the rights to use it in different ways. I saw the news yesterday on the Swedish television, and they were saying about children that they are quite mature today because they know that they shouldn't put everything in public on Facebook. You should only include your friends, etc. But of course, I don't think they realize that the photos they're taken are owned by Instagram or Facebook, for example. And what will happen in 10 years when we have too much photos into the cloud? Maybe they can, okay, now I will take away the past 10 years of your photos because I own them. So that's need to be considered about. Well, all this consume energy somehow when I'm loading my mobile phone, when I'm using energy to use this for the webinar, projector, etc. And IT services is sort of in the seat how we will use the energy and how much we need to use. We need our workstations. We need the interconnection between our workstation to out to the internet or out to the world. I spoke a lot about the mobile phone. I like my mobile phone, and I will probably use it a lot today and later on today and tomorrow and the day after. The tablets, and of course the cloud. I mean, even if we don't see the servers we are using now for the webcast, for example, somewhere a server is standing, taking care of all the information. We are recording it. We will use it on YouTube afterwards, and that consumes energy, and it's very hard to affect. But if we focus a bit on the server room alone, what is a server room? I mean, this could be, it's not a very big server room. It's a mid-sized company, such as Swegon, I would say. It's not a megawatt data center. It's a server room with 30 kilowatts. But it's using 30 kilowatts 24 hours a day, 7 days a week, 365 days per year. And just to give you a sort of thought how much money it costs to run our service for our company, it would be, and if we're looking on the average price for electricity, in Europe it was 0.12 euros per kilowatt hour. So 30 kilowatts, 24 hours a day, 365 days, it becomes 31,536 euros per year. And that's quite a lot. And it's not the biggest company in the world. It's a mid-sized company. But of course, not only the server room is using electricity. We have also the equipment around it. We have the cooling, for example, because all the heat is, all the energy is wasted as heat somehow. We have the cooling machines outside, producing cold water. We have the cooling machines inside the room to keep it cool enough. We have the UPS system, providing it keeping it safe from thunderstorms, for example, and also keeping it running if you have a power break for a couple of seconds until the diesel generator starts, or a couple of minutes you can take down your RT equipment safely. We have the ventilation system. We have the security system with the cameras, etc. And we have the lighting. So it's a lot of things consuming energy just to keep our IT running. And all needed to support our service 24/7. And therefore, the IT industry came up with a good way to measure this and talking about PUE. And it's a very well-known and accepted way to see how effective your data center is. And you can quite simply, because you actually look on after the UPS, you can see how much your IT load is running at. How many kilowatts is your IT equipment with your servers, routers, etc. consuming? And then on the other hand, you can see the total power to the data room or to the data center, where you can actually see the cooling system, the UPSs, lighting, etc. And then you divide it. So if we look on this example for the mid-size server room, we have the IT equipment, and you remember 30 kilowatts, 24 hours a day, 365 days per year. And you remember the cost, 31,000 euros approximately. And let's say that we have supporting equipment using not as much, but half of it. It will mean 15 kilowatts. So a cost of 15,000 euros per year. And that would give us a POE of 1.5. It's not very bad and it's not very good, but it's a POE of 1.5. Some facts about POE is that many data center server rooms globally is running with a POE of over 2.0 and even higher. I thought Morgan on the train here talked about global average of 2.5, 2.7 something, and it's a lot of energy. And we're talking about the total energy that the IT industry is using. It's huge. It's huge. And we're talking about that the carbon footprint of the IT is higher than from the air industry, for example. So it's really a lot of money to save. So if each data center could cut down from 2.0, 2.5 down to 1.2, for example, or lower, it would mean a lot for the energy consumption in the world. And we're quite good at it here in Nordic because we can use free cooling using the cold climate outside, so we can actually cut it down, either with a direct system or indirect system. I know Lucio will talk later on today about the techniques behind it. And of course the cooling system has the greatest impact about the POE. It's the easiest way to cut down is to look on your cooling system and what techniques you are using. Many colocation providers and cloud companies manage to run the data center below 1.2 as POE. And Facebook, for example, claims that they can run the data center at full load at 1.07, which is very low. So it's very, very low to run the data center, except from the IT equipment. And in our example of this small server room, just by, for example, using free cooling somehow, some more efficient UPS system, be clever in how you built your data center. And if we could cut down from 1.5 to 1.2, it would mean almost 10,000 euros per year. And that's quite a lot of money. And if you have a data center at 1 megawatt or 2 megawatts or 30 megawatts, it's a lot of money. So fact is, money talks. A green dollar. Anyway, when we're talking about POE, it's not allowed to go under 1.0 if you're using the measure method POE. So you cannot have a negative POE. And therefore, the green grid, talking about ERE, if you can actually take care of your waste energy somehow. So in that case, you are looking for the data center, but you're also looking about all the reused energy you can take care of. And in that case, it's not 1.0 that is the aim, it's lower, even lower. And I think this will come a lot in the future. And facts about ERE is that we have been seeing a very, very strong effort in the Nordics lately. We try to focus to take care of the heat load, maybe into a district heating system. We have good examples of that. We have Apple in Denmark. Apple actually placed a data center because of the possibilities to use to sell the energy somehow to the Copenhagen. We also have Fortum here in Stockholm buying the energy from the data centers. We have Eco Data Center in Falun, which is a carbon negative data center. Taking care of the heat and also using the heat to produce electricity of it. But still, PoE will be a good way to measure your data center. If you're a data center owner, it's probably the best way to see the partial PoE of the cooling system or on the UPS system, and see how you can cut down your energy consumption. So we will still have PoE a while longer. But I'm very sure that the market in the future will come up with some new methods where we can combine PoE and ERE or something else. We can actually have good ways to measure it and state out that we are a very good data center provider. I wouldn't say that we have a good way to measure it yet, but it will come for sure. So money talks even there. But it's not all about the money. We had an old song called All About the Money, but it's not all about the money. It's also about your data center, how safe if it's, how much can I rely on my data center? As I said earlier when we spoke about if I'm going to use my banking using IT, I don't want the IT to go down. And the cheapest way would probably be to just put my server out in the forest, especially on a winter day. But I need to count that the IT will actually work when I need it. And therefore we have something called tier standards driven from the Uptime Institute, and that's actually talking about how safe is my data center. How safe will my data center be if I'm using tier 1, tier 2, tier 3 or tier 4? So, and it can be quite hard if you not come from the IT industry. I was on a meeting a couple of years ago where a big hospital wanted to use tier standards into the data center. They wanted to be a tier 3. And they used the normal consultants on electricity, on cooling, etc., etc. But they never heard of tier. So it's very important for the industry to meet, I would say, with the traditional consultants together with the IT people, that we actually meet and talking the same language. Because we have a lot of standards for electricity, etc. But tier is something that's very common for the IT industry. And I said we have 4 different levels of tier. Tier 1 is the lowest, and that would actually be that you have 1 UPS, 1 cooling machine to your servers, and if something happens, it may go down. And to make it easy, tier 4, you have almost double it everything. And of course, it means a lot. The difference, if I have a tier 1, for example, 99.67, it seems quite high, doesn't it? But it's about 8 hours per 8-9 hours per year, even higher. So you want to cut that down. And if you are a bank, for example, you should never go down. So this is a tier 4 example. As I said, it means that you have double feeds on the power from the power grid. You have double electrical distribution. You don't need to have double UPSs, but you need to have a UPS on at least one side. And you actually support the servers, the critical load, with double feeds all the way in. And also the cooling needs to be completely redundant. And that also means that you can't use, for example, district water. I mean that we have in the tap to reach a Tier 4, because you need to have control over it the whole way from the beginning to the end. And it's quite rare, I would say. The most data centers within the Nordics is Tier 2 plus, I would say. We have some customers aiming for Tier 4 to Tier 3. And we have some new data centers starting to build Tier 4 in Scandinavia. And for some customers, it will be very, very important to have high security about the data center. Some facts about this. Of course, if you need higher redundancy, you also raise your your carbon footprint, because you can't run as effective as you can if you only use one path or if you don't care about the safety at all. So it will increase your carbon footprint to go for a Tier 4 if you don't try to take care of the energy somehow. Also, the standards, existing standards, not all are actually able to use for 24/7. For example, we have some standards saying that you should put out fire with water. Also standards for data center. And that means that if we should actually put out the power for the data center and then started to bring in water, the system will stop for many days. And it's not so easy actually to just swap over to a new data center and run it from there. A standard takes quite a long time to be accepted. I have been heard about Tier for maybe 10 years now. But as I said earlier, on that meeting with the consultants and the IT customer, they never heard of Tier. So we have a lot to do to educate the market within these topics. And the problem is, of course, is that the IT industry is moving extremely fast. So what was news yesterday or maybe not news tomorrow. It's old news tomorrow when we come that far. And sometimes standard also can hold back innovation, because if you're aiming for be a classified Tier 4 or Tier 3 data center, and you have some really brilliant idea, but you can't really fit them into the standard, and you can be quite sure that you still can have a very, very safe data center, you maybe not possible to get it classified. And that's what I mean, that it might hold back innovation. So it can be a struggle between standards and real life, I would say, since we are moving so very, very fast in this industry. But it's not all about the security either. It's about sustainability, the future. Our kids need to live and breathe in this world tomorrow and in 20 years or and in 50 years. So we also have some new standards for this, and we have something called EU Code of Conduct for data centers. It's started to be quite well known within the industry, but for many people today it's still completely new. And it's actually helping the customers to be more environmental friendly, to be more safe, and also by learning from each other how we can improve our operational efficiencies, and of course about taking down the energy costs. So I think that we people from the data center industry have been quite aware for a long time that it's a growing problem with all this energy need. So this EU Code of Conduct was established actually to help us. to affect this increase and the energy consumption to take it down. So what does it do? Its purpose is to inform and encourage data center operators and owners to bring down their energy consumption in a very cost-effective way. It also wants us to improve our understanding about the data center and the energy need by raising awareness, and also recommend the best practice. If someone doing something very good, we can also recommend it to someone else. It should be open and learn from each other. And of course, if you participate in this, you actually help you to put down your carbon footprint in the world. And you can participate by either being participant, meaning that you have quite a lot of job to do, because you need to document the full data center. What energy sources do you using? Is it green electricity? How do I do with all my waste in the data center? What do I do with my servers after they are there? What techniques do I use? Do I use free cooling? Do I use high voltage UPS system, etc., etc.? So it's a lot of job and a lot of documentation to be done. Or you can participate as a endorser in different levels. And as an endorser, for example, manufacturers like us could be endorsers. And we could also need to actually talk, okay, how do we actually going to use this standard to improve our products, our way to work? But it's a lot of job. But it's not cost anything to do it from EU, but it costs a lot maybe to have it documented. And I believe when people and companies start to be aware of this, it will affect the market. And also data center providers will be asked for, okay, are you working with EU Code of Conduct or not? And in that case, it's quite good to know that it exists at least. And of course, you should work with it. And for manufacturers, it will also play an important role, I would say, because already today I seen it and heard it from customers saying to a manufacturer, okay, how do you work with EU Code of Conduct? Do you work with it? And in that case, you need to know what it is, you need to know how it works, and you know to actually be able to explain that yes, we are working with it, and we are doing this, and this, for example. New consultant services. As I said, it's a lot of documentation behind it. And it takes a while, and you need to have a good understanding about the data center, but also about electricity, cooling, IT, etc., etc. And that means that it will be a good way for consultant companies to be specialists in this. Because when I, as a manufacturer, or you as data center providers want to certify your data center, you probably will need help because you want to do your own business as usual. And I know in Sweden, for example, we have some very good consultants today doing this. And of course, if we have a EU-financed project, we can be quite sure that they will demand that we are following EU Code of Conduct in the future. If they're going to pay us a lot of money to be able to raise this new data center or new business, they probably want us to follow their code of conduct, at least. And of course, it will put down the carbon footprint for us if we're using it in a proper way. As Petra said in the beginning, how much IT will be used in 3 years? Can anyone here give me a number? How much will we use? I have no idea. I only know that it will continue to grow. In all we do, it will continue to grow. In our cars, in our houses, in our doors. And the biggest challenge about that is that we actually, when you're buying a new server at home or a new laptop or whatever, it's quite cheap and you can probably throw it away in 2-3 years or maybe 5 years. But when you're planning for a new megawatt data center somewhere in the world, it's a cost of millions of euros to build it. How should we think? Because that data center is probably going to last for at least 15 to 20 years. And that's a very big effort for us and try to be as innovative as possible to actually be able to cope and last for all years. So building steps is one way to do it, and they try to do it, and also modularity. We have seen a lot of data centers building in modules today, starting to, and it can also be containerized, for example, that you have a IT container for 50 kilowatts, 100 kilowatts, 200 kilowatts, etc. And that's one way to actually build in with one piece of your data center, and then you add the next piece, and then you add the next piece, and you can probably also move your pieces somewhere. So that's a trend we have been seeing a lot, but not so much yet. I think it will continue to grow. And of course, pay as you grow. That's what you want to do. The cloud services will have a great or huge impact of the industry. And a cloud could be an internet cloud, or where we actually put up our pictures, or we use Office 365 using the service then somewhere else. But it can also be a private cloud, that we actually built our own cloud between our offices into a big data center. And it will be cheaper, of course, to rent somewhere if it's instead of maybe build your own huge data center, not knowing the future. So you can actually rent a small place, you can move it, you can choose new providers. So we have seen a big trend. It's a lot of new cloud providers in Sweden. We have Google in Finland. We have Facebook in Sweden. We have Apple in Denmark. So this will grow. And that means also that in your own data center, it will probably be smaller. That you have 1 or 2 racks, 3 racks, communicating with this cloud somewhere. The interconnection will be extremely important, because if I'm going to put my servers somewhere in the world, I don't in Sweden or in Holland or in UK or US, the latency is very important, and also that you have stable interconnection between in your office and out to the world outside. So the fiber, the cabling will be extremely important in the future. And of course, environmental and security issues is also very important. As I said before, just agreeing about the new rules for your Instagram or Facebook, whatever. But also we want to be online all the time. So if you have Wi-Fi, for example, in your phones, which you have, we want to be so much online that we probably wanted to seek wherever we are, and then we find a new free Wi-Fi, perfect, and we just click into it. I have been on a workshop where someone actually took over my phone by just pressing the Wi-Fi, which was stronger than all other Wi-Fis around, and it seemed to be very free. And just by pressing it, he could control my phone. He could see if I put in my credit card numbers, etc., etc. So it's going to be very fast, and it's going to grow a lot, but we need to be very careful. So the security issues will be very important. And I also think that we will have some new regulations created from the government, of course, but also from the providers. I mean, is it okay for us to bring in how many pictures as we want? How long can we keep them? Is it okay for the future that we consuming much electricity each time we want to show that movie for our family or our friends? We don't know. So perhaps we will have some new regulations also in the future.